All right. Hello, everyone, and welcome to our webinar on LF Broadband. My name is Michelle Roth, and I'm the Senior Project Coordinator for LF Broadband. I'm very pleased to be joined by my colleagues from the Linux Foundation, members of the LF Broadband Governing Board and Technical Steering Team, and contributors from the community today. We're excited to share with you our vision for LF Broadband, specifically the future of disaggregated broadband access that aims to accelerate the development and adoption of open source software for broadband networks. We have a robust agenda today, and we'll be answering your questions throughout. If you'd like to submit a question, please use the Q&A button at the bottom of the Zoom window. We'll do our best to get to all of them. With that, I'd like to welcome Arpit Joshipura, General Manager of Networking and Orchestration at the Linux Foundation and Executive Director of Broadband. Take it away, Arpit.
Thanks, Michelle. All right, Dan, let's go ahead and start the slide. So first of all, really appreciate everybody being on the call. And I'm assuming you can see the screen. Linux Foundation goal is to create the largest shared technology investment. So for those of you who are not familiar with Linux Foundation, we are the largest nonprofit organization. We build ecosystems, we build collaboration, we help with open source technology and commercial adoption at a global scale. If you go to the next slide, people need to know that we are well beyond Linux, as the name suggests. We host over 1,000 projects, either in a vertical industry or in a technology industry, or in a technology like blockchain or AI or things like that, like a horizontal or a vertical. We won't go into all of this, but you can see the scope and the breadth of what we host and how we build ecosystems around it, whether it's the telecom industry or the automotive or the finance or the energy. So if you go to the next slide, I think we can get a very simple bird's eye view of how everything fits together from a networking perspective, including access and edge. I'm going to start off with the left-hand side, which is connectivity. And we look at connectivity in three big buckets. There's the 3GPP and the RAN and the O-RAN connectivity, mobile broadband, which is on the top. So we host an O-RAN software community for that, projects in SD-RAN, partnerships with OAI, etc. Then today, where we are talking about is the LF Broadband, which is the largest open source foundation for disaggregated GPON and open broadband access. So we'll talk about that particular sub-foundation today. And then there is the alternate connectivity called LF connectivity, which is really, fixed wireless or 60 gigahertz or, rural access or things like that, beyond the broadband. So those are the mechanisms by which you enter or access the connectivity. And then you get into edge compute, which is really the framework of uniting IoT edge, telco edge, enterprise edge, and telecom edge. And then moving into the cloud or the core, up and down the stack from a network operating system all the way up to Kubernetes, automation, and API and application. So this is kind of just a sample project or set of projects that make up end-to-end open source networking, fixed or mobile. Okay, so if you go to the next slide, let's double click on the market direction. So one of the things that we'll get a lot more into details, and I'm just going to set up the market problem and where we are heading, and then we will have deeper and deeper discussions as we go along, including how we are building things, how actual projects work, including the bits and bytes behind the scenes. So, I'm first of all so glad you all have joined. I just waited for a couple of minutes to welcome you all, just so that we have the crew in here. But let's go with the direction of this market. Requirements are very simple: speed, uplink, downlink, reliability, reuse existing equipment, and it needs to be open and interoperable. And you can see the technology expansions from initial deployment to brownfield, fiber cable, CMTS, central office, new fiber build out, doesn't matter. Speeds go up, but if you introduce complexity, nobody wins. So let's go to the next slide and see what the challenges are. So as you expand the fiber, you cannot just simply replace FTTX, and you cannot just put fiber. It's very capital intensive. You cannot also disrupt the supply chain because you can have chipset shortages, you will have equipment shortages, etc. And the most important thing is reliance on a single vendor creates a risk, and fragmentation leads to interrupt issues. All of these are what we are working to address. So if you look at the next slide, it really points to what has happened outside the broadband. And we need to know this because exactly what has happened in the rest of the ecosystem is what's happening to broadband access. And it's all what I summarize as disaggregation and automation. And disaggregation is essentially separating hardware from software, control plane from data plane, and then using generic hardware and, more importantly, open source software to allow for rapid deployment, innovation, lowering cost, and interoperability. If you go to the next slide, how do we see the transition happening? On the left is your classic legacy systems, and then on the right is where you have a more horizontal open source suite. You can see that the big thing on OSS BSS is you're just doing one time, and then you have a layer here which allows for full compatibility of OLTs, ONTs, and allowing for PON management. Okay, and if you go to the next slide, I think we can sort of give you the details, or at least an overview of what LF Broadband is. So LF Broadband is a sub foundation, you may call it, or a directed fund in a technical sense, that was established late in 2023. So it's been almost operational for a year. And it was set up as we moved to most important project in the PON industry to the Linux Foundation. They used to be hosted by Open Networking Foundation, and that merged here. And so two projects, SEBA and VOLTHA, are what we're going to talk about in a lot more detail today. Okay, so that's LF Broadband. If you go to the next slide, what we are seeing globally, and in the next 2 years, we'll see more and more of this as the demand for bandwidth and the demand for lower latency goes up and up, is people, operators and vendors really care about broadband. And what does LF Broadband do? The first thing it does is it's open. So open source and open interfaces, and that makes it future-proof because it's a cloud-native architecture. We've seen the scale at which the deployment happens, and you will hear from some of the leaders in the industry today on this webinar. It is a multi-vendor platform, which means multiple ecosystem vendors, multiple solution providers, system integrators, they all can work together, and you can mix and match. And the best part of it is technically, it's the cleanest solution for multi-protocols or centralized management. And the true, what I call, benefits of SDN. I was involved in sort of SDN, a decade or so ago, when it was being created. And I'm very excited to see this now happening, not just in the core and control plane of the cloud, but all the way to the access, right? And RAN is also going through the similar disaggregation and transition. So we're really excited about the broadband, or at least a fixed broadband. And by the way, this LF Broadband is the only open source foundation that you can participate. And we have seen numbers that blow away your mind, right, in terms of TCO savings. So let's kind of hear the details and see where things are heading. So if you go to the next slide, I think that's a quick summary. SEBA and VOLTHA, one is a reference design, the other one is a open source project, which is, again, I won't go into these things, but we'll hear it from the experts on why these projects are so important for the next 5 years to come, as things start converge, as things start getting disaggregated, and as things start becoming completely open source. Okay. All right. So with that, I think I'm just going to sort of end with one final statement, which is in the world of broadband, there's a whole set of standards. I remember coding to some of the very, very early standards, like I think 303 or 69 or things like that. And there were very few, but now there are a lot of broadband bodies, standard bodies, that are aiming to standardize how interoperability happens. So the best part of broadband or LF broadband is we are partnering with these standards to make sure that standards and open source, they work in conjunction and they are working in cohesion, because you don't want open source to be the de facto standard and now standards are going one way. So we've got MOUs and partnerships, and we are aligning extremely carefully. So the good news is there's a standard, it will be implemented in the open source. If there is no standard, open source will implement it and upstream it into the standards. That's how we have been working with the standard bodies. Okay. So with that said, I think let's just hand it over to Manuel and Mehmet, who are governing board members of the Linux Foundation LF Broadband, and they will talk about the operator view, right? That's a most important part of this presentation, because when you have an end user view, you know where things are heading. Okay, so take it away. Thank you.
Thanks very much, Arpit, for this great introduction. It has certainly been a journey, and it has also been a pleasure working with the community. So having heard from Arpit about the major drivers why operators and the industry at large has driven disaggregated broadband networks, I've actually put the title and also the key message. It is a path really worth taking. So it's really rewarding to build disaggregated broadband networks with open source and open standards. So on the next slide, actually it's a summary from this journey and the really key contributions that have been made by major industry and standards bodies. And obviously we're at a pretty high level of maturity for base solutions. There is a lot more to come, and there are established places to walk, and certainly with the transition from ONF to Linux Foundation Broadband that from Deutsche Telekom side we have wholeheartedly supported and have really seen as a great move to further foster this in the meantime mature walk with VOLTHA, very, very key, but also the collaboration with Broadband Forum. So we are really in a great and advanced stage. However, from the perspective of what to do with open source, as I said, there are many more opportunities, and the theme of collaboration is really key. Also, of course, from the perspective of new solution entrants, there are still seats on the table, and the opportunities are manifold. So with this view, we just recognize that, of course, no operator, not even large suppliers, can do this transition alone. And so that's why we have really enjoyed, but we also have seen really this productive collaboration coming to fruition thanks to the community work. And it is not a play, it is not a just innovation game, it is really very, very serious and relevant for production deployments. As we will see, next slide, please. Since looking at the software evolution, if you can just move one more slide forward, please. Yes, thanks. Now we have it. We see. Oh, that was one too much. I apologize. Maybe there's a bit of delay over here. So talking about number 20, we see the evolution that the industry has taken, and we are not at the end of it. With containerized infrastructures and cloud-centric deployments, pretty much just getting into production in the different network domains. So here for the broadband access, this is a very key domain for telecom operators. And obviously there is a very high stake in deployments, in existing deployments that needs to be considered. And well, the message here is, it is possible to do this transition and to really take what has been enabled through modern microservice architectures and the concepts of SDN and programmability, applying those to really the bread and butter network domain, the access network for telecom, for telecom operators, and make those solutions scalable. And well, here it is, VOLTHA, the project that has arisen thanks to a number of operators that got together and jump-started it together with ONF in the time where SDN and microservice architectures entered into the telco domain. So now we are really looking at a set and established and mature set of solutions that are available in open source and that allow for open cloud native and disaggregated broadband solutions. And thanks to the efforts that have been taken by the community on software development, but also on testing and bringing real-world use cases to the table, the solution available with VOLTHA and the SEBA framework allow for the solutions being built really rapidly with a really fast time to market, which is particularly important for multi-vendor networks, looking at, as I said, evolving networks, not just networks that are greenfield, which can benefit from pretty much the opportunity to build something brand new, but also the networks that are large scale and already pretty established, like the network we are looking at for many markets in Deutsche Telekom's purview. So here we have actually really, as I said, achieved, thanks to the VOLTHA project and the collaboration with the community, a production-grade solution that is used in Access 4.0's PON network controller. And the platform itself is larger, is bigger. We have talked about it, so I don't want to go into all of the other domains that are also relevant and in transition and have been seeing really a generational transformation, which includes building the whole telco cloud central office as actually really a set of functions that are cloud-centric, deployment that is cloud-centric, that is benefiting from the software life cycles rather than being tightly coupled to hardware life cycles of the past. And the most important point is really to improve flexibility, to increase automation. That actually is thanks to software components that are available and are well tested. And now, as said, a key theme is that these solutions are also available to be deployed at scale. And from the perspective of what has made the key difference, the focus on real-world use cases and getting started with implementations and taking these implementations as a basis to influence the standards. This has been really the right path to break through a bit of the chasm as well, to enable new hardware models to be also covered and still support, as said, the already deployed networks, access networks, and even allow for smooth migration, like it has been our requirement at Deutsche Telekom. So from the perspective of what VOLTHA supports today, it is a multi-vendor PON network. It is not just an OLT control plane by far, but it is really a full management and controller solution that is building on top of the open source and is using VOLTHA. And from that perspective, we have really achieved the initial goal, but yet more there is to come. And if we move one slide forward now, then I will recognize that there is going to be more details coming for how the solution exactly looks like, how the VOLTHA project evolves. So I don't want to take the next speakers, I don't want to take away their meat, but just to sum up and also look forward, from our point of view, we can conclude that open is the right way to go and to scale. It has been really key to establish a working and implementation-driven set of open source solutions to break through the chasm to get this new set of solutions and the transformation going. So those solutions are here thanks to the VOLTHA project, the SEBA framework, and the community that has worked on it. Operator driven is key. It remains key. It is also key to align with standards and collaborate. So this is what we have been seeing thanks to the effort done by the community and underpinned by Linux Foundation Broadband in the partnership with Broadband Forum. Very, very key to really leverage the synergies of open source and standards. So now looking forward, we have FTTH and even, of course, also FTTB, so FTTX platforms that can facilitate service innovation, that are ready for the new features, and also thanks to then those features getting introduced very rapidly, new services. And what is also possible is network convergence, not just on the infrastructure level, but also on the functional level. So talking about fixed and mobile. So the key area, the key bread and butter, which is broadband access, has benefited from this transition and is continuing on the transformation. And so are we with Deutsche Telekom. And at this point, looking forward to this continuation of the collaboration, further deepening it. And with that, I would like to hand back over to you, Arpit. Thanks.
All right. Go ahead, Dr. Mehmet.
Hi. Thank you, Manuel. I would like to start with open is the right way, like Manuel said. Hi all, my name is Mehmet Özdem. I am working as Network Architecture and Service Management Director at Türk Telekom and co-chair of Linux Foundation Broadband. Today, I'll talk about Türk Telekom's fixed access virtualization journey. Next slide, please. Okay, firstly, I would like to share some numbers with you. As of Türk Telekom, we are providing fixed, mobile, TV, and value-added services to our customers to over 53 million subscribers. We have really big, very huge infrastructure, fiber infrastructure. It's about 459,000 kilometers of length. According to the last FTTH Council Europe report, we are the #2 in Europe in terms of the FTTBH home pass. As you see, as of Türk Telekom, we have 8 different subsidiaries, group companies, research and development company, international part, integration company, call centers, ventures, financial, payment, and education technologies companies we have. Next slide, please. I believe the production phase starts with the innovations. Here we encourage patent work in Türk Telekom. In this context, we have over 1,500 patents, in which we have 100 plus international patents. You see here our patent distribution, such as VRAN, slicing, UTM, SEBA, SDN, security AI, cloudification, and so on. Next slide, please. Today, Türk Telekom has become a technology developing operator instead of being just a consumer. We have created and commercialized great achievement with GNSS independent synchronization technologies, which is the world's first deployment actually in Turkey. Other one is radio intelligent controller, RIC. We productized RIC technology with Juniper and SEBA. We developed SEBA with our subsidiary Netsia and XONF. We are the first operator in the world to commercialize and deploy SEBA technology. Today, I will give some details about the SEBA. Next slide, please. You see here SEBA benefits. The biggest benefit is that SEBA architecture allows vendor independency in the fixed access domain. All the features are created by open source and operator labs. For operators, SEBA creates a single point of integration for the whole access domain. Due to the benefits of SEBA, we do not want to invest in legacy technologies as Türk Telekom. For this reason, we have now directed all our investment to the virtualization, I mean to the SEBA in fixed access domain. It's our main strategy. Please, next slide. You see here are SEBA contributions. Türk Telekom contributed to open source for SEBA to mature. We have addressed important features so that SEBA can be used as legacy equipments in our network. You see some of these features such as multi-TCONT, multi-service, IPTV multicast service, GPON technologies was important contribution from us, VLAN-based flows, remote software upgrades. All these contributions we did to mature this product. Please, next slide. Türk Telekom does detailed testing in its own innovation lab as well. Stability, as you know, stability and scalability are the keys to use a technology in production. Here in our labs, we do this test with a variety of the vendor equipments. In our lab environment, we have more than thousands of ONTs and 5 different OLTs running daily tests. This lab can also be used by another parties. For interested operators, vendors, we can get in touch after this presentation. That's why we have written at the right side, you see ready to share. We are ready to share for other operators and ecosystems. Please, next slide. Here you can see our end-to-end SEBA architecture, SEBA live deployment architecture. We use white box OLTs and ONTs in our production environment. We deployed SEBA Central, it's called NetSIA BB Suite as central management. And now we have reached 120,000 home pass, FTTH home pass, with 69 OLTs. It is the world's first commercialized network, actually. Please, next slide. We can say that SEBA is now a mature product. It is certain. Here you can see the entire process we went through to mature the product. We matured it together with the open source community. In this way, new operators can use these products that have been created without going through the first phases. You see all phases we done, completed, and ongoing phases. Please, next slide. This is the map of Turkey, our country, and you see our SEBA deployments through Turkey, whole country. The locations you see in green are where our white box OLTs are located. The number of OLTs are growing every day, and we are spreading them throughout the country. And blue color represents SEBA edge points. SEBA can be controlled from 2 centers in geographically redundant structure, as you see. Please, next slide. Okay, this is the my final slide, actually. SEBA is a mature product. and ready for mass deployments. With Linux Foundation community, we want to explore new innovations for SEBA, such as cloud native, zero-touch provisioning, telemetry, AI is very vital for us, DPI, time synchronization, traffic steering, and virtual BNG. We can only achieve this by creating a strong ecosystem. Finally, I would like to invite all operators, vendors to be part of this strong ecosystem. Thank you very much.
Great. Thank you, Dr. Özdem. So at this time, we're going to move over to the supplier panel. So I'd like to welcome Bora Ilicic from Netsia, Mitya Golya from Kontron, and Carla Pilitu from Digital Platforms. Welcome, everyone. To start this panel, can each of you please provide a short introduction to your company and your role? We'll start with Bora and then Mitya and then Carla. So Bora, please go ahead.
So yeah, I'm Bora Ilicic, and thank you very much for the introduction, Michelle. I'm leading Netsia and the proud member of LF Broadband's governing board, which is the largest broadband open source initiative, as Arpit just mentioned. I like that. So Netsia is all about innovation in the telco space and open source. And telco grade solutions is all I want to say today.
Okay. And I think you had some slides that you wanted to go through. Did you want to go through those now?
Yeah, sure thing. Yeah, maybe just we can skip the next one. And I also covered this one. Yeah, so let me just reiterate the challenges in the broadband space. It was some 6 years ago, 7 years ago, and it's still the case that there is a need for fiber expansion, and the need is ever growing. And it was even more become visible during the pandemic times. And so the industry needs to roll out more and more fiber. But the broadband can only be addressed best with fiber, as we believe, as other technologies in this way or the other will fall short to address that demand. So yes, you're going to lay out so much fiber, but who's going to provide that? So there are so few vendors, and it really slows down the equipment acquisition, and as well as even if you get opportunity to obtain your equipment, you will find yourself in such a way that locked into your existing vendors, because it's not easy to introduce a new vendor into your vendor list in your network. So with all of these challenges in front of us, next slide, please. We have identified 3 principles to cure that need, to cure those challenges. And those principles are openness and making something cloud native and make it future-proof. Openness, I mean, we have heard from Arpit, from Manuel, from Mehmet, is key for everyone. And this is going to be the key concept that will actually make things faster and actually more, let's say, mature and fulfilling. And when you make things open, that means you are mobilizing an ecosystem. And for an ecosystem to work all together, you need an environment that supports it. And cloud nativeness is the answer to that, as it is providing everyone with a standardized, simple, but yet scalable and high-performant environment for all the software and solutions you're creating. And as future-proofness, the fiber we're going to lay down today is going to be there for another at least 50 years. And you have to have something in place that can adapt changes and new requirements and new features along the way down the road. Whether it's going to be a transitioning from 5G to 6G to 7G, whatever it's going to be, you need a platform that is flexible enough and adaptable. Next slide, please. So with those three principles, we have built Netsia Broadband Suite. And Netsia Broadband Suite is a cloud-native, multi-vendor, field-proven fiber broadband platform. And it is based on open source, open interfaces, and open standards. Next slide, please. And yeah, we did this for a reason. The benefits the platform is expected to deliver is actually cost-effective and flexible upon sourcing. What makes this possible is the fact that service providers, with the help of an open and multi-vendor platform, can invite even more parties to their tenders, and that will ignite both competition and innovation. And as I said earlier, cloud-native open platform brings in agility, meaning that you don't have to wait long cycles of 18 months, 12 months, whatever, to refresh your install base. You can even do daily upgrades as the rest of the IT world is doing today on a cloud-native environment. And also, another benefit we have observed is the unification of the OSS/BSS integration. So what we bring in is a single pane of glass that helps you manage various different equipment vendors' equipment, and you treat them as just one single OLT type or one single ONT types. You don't have to really worry about what system you're dealing with. Maybe even more important, the OSS/BSS integration you're going to do for Netsia BB Suite will be the last one you will be doing. You won't need to revisit your OSS/BSS integrations every time you introduce a new vendor. Next slide, please. And so these benefits are not just, some paperwork. Netsia BB Suite is in production. Next slide, please. And I'll share with you a few numbers. But before that, here's some highlights from our footprints globally, just to say that we've been active around every corner in the world with various tier 1 operators, whether they will have just a simple POC or a large-scale production deployment. Next slide, please. And now we can confidently say that Netsia BB Suite has kept its promises in terms of CapEx efficiencies. We are seeing up to 40, maybe even more CapEx efficiencies, as well as up to 20% OpEx efficiencies. And I totally agree with Arpit's up to 60% OpEx efficiency. The platform has the potential to go up to 60% as we will progress with more and more vendors covered by the platform. Next slide, please. And not only financially we have achieved our goals, Netsia BB Suite has gone above and beyond, also technically speaking. What we observe is 5 times less downtime and 8 times less trouble tickets. And with that, I'm going to conclude my presentation. Thank you very much for your attention.
Great. Thank you, Bora. We'll hand it over to Mitya.
Yes. Hi, my name is Mitya Golja, and I come from Kontron Slovenia. Kontron Slovenia is a member of Kontron Group. So I work as a business development director in Kontron Slovenia, former Iskratel, and I'm also leading the product management team. So if we go to the next slide, I will give a couple of words about Kontron Group. So as you can see from this slide, Kontron Group is quite a big corporation. It's a public corporation listed on Frankfurt Stock Exchange, and it works in many different industries. So Kontron Slovenia is the main company in the group responsible for telecommunication. And we are covering also very strongly the IoT sectors in different vertical industries like transport, aerospace, green technologies, industrial IoT, and different services. So the corporation is quite big, around 8,000 employees, and we are present in more than 20 countries around the globe. Next slide, please. So what do we do in Kontron Slovenia? So we offer different broadband solutions. And here on this slide, you can see some of our key products. So mainly in the area of broadband access. So we are focused in supporting different broadband access products like OLTs and supporting different PON technologies and point-to-point technologies. With these products, we can deploy solutions for different areas like urban areas, suburban and rural areas, and also offering services for residential and business customers. The most important part of these products is that actually they work as traditional OLTs, or just with a software upgrade, they work as a disaggregated, virtualized OLT. So they are some kind of amphibian. That's why we have this nice frog there. So these products are used already today in deployment in the disaggregated networks. And next slide, please. Yes, we are proud to cooperate together with our partners in deploying these solutions in different countries. So we have just recently deployed this SDA, software-defined access solution, to one very important big customer in Germany, together with our partners. So my previous presenter, so Nizia. And for this solution, it's very important that it can support different kind of architecture. So from the SEBA architecture, which was presented in the beginning, it's important that this solution can support also the solution proposed by Broadband Forum, so the OBBAA, and that it's open for the future, so that it can support in both architectures, the legacy equipment, so-called black boxes, then gray boxes, and also the white box, which are completely disaggregated. So in Kontron Slovenia, we are focusing in providing end-to-end solutions. We see many good movement on the market, so from the big tier 1 operators, but also, let's say, challengers on the market, like alternative operators, are showing the interest for such solution. So that's for my initial part. I give the word to the next speaker. We have one more slide. But yeah, I think Bora already mentioned the biggest benefits of disaggregated solutions. So vendor lock-in. So with open solutions, you avoid, of course, the vendor locking of traditional solutions. We've seen the numbers of more cost-effective scaling and easier integration. And of course, if you integrate it once into the OSS BSS system, then you don't need to do further integrations with introduction of new vendors. Thank you for initial part.
Great. Thank you, Mitya. Carla, would you like to do your introduction now?
Good afternoon to everyone. Let me start with a brief introduction to our company, Digital Platforms. The next slide, please. Digital Platform is an Italian company with 52 years of experience in the energy and telecommunication sectors. Digital Platforms design highly secure and reliable automation and telecommunication solution for critical infrastructures, for critical network infrastructures. And over the years, we developed a clear also practical perspective on tackling the challenges of network disaggregation. And the next slide, please. So our Samba 16 is a 16-port multi-PON white box and supporting combo PON, GPON, XGS PON, and sure, with software based on SEBA, VOLTHA, ONFs, reference architecture. And Samba can be used in a multi-vendor environment and support both centralized and distributed SD-PON software. We are ready to embrace also technological, the last technological advancement. This includes 32 and 48 ports and optimize the power consumption, which we are actively working on. Our Samba solution is not just a disaggregated OLT, it's also open to the edge ecosystem, for example, smart cities, thanks to the know-how that we developed in our laboratory in Italy. And we have a comprehensive testing laboratory in Italy. For example, a concrete example is that in 2023 with Netia, we began collaborating and conducting different testing together. Our architecture is built on SEBA and LF, on LF and SEBA, BBF net Confeyan, and on our roadmap. The next slide, please. The BBF protocols integration is very important for us to promote a further interoperability. And we have one key request. We need greater availability from vendors to conduct interoperability tests according to BBF protocols and concerning OLT disaggregation. In accordance with the partnership between Linux Foundation Broadband and the Broadband Forum, the developer native connectors of a software to the net Confeyan protocol used by the major TLC operators will be completed. Thank you.
Great. Thank you, Carla. So I have a few questions to ask our panelists, but I'd also want to remind our attendees that if you would like to ask any questions, you can submit those through the Q&A module at the bottom of your screen, and we'll do our best to get to them if we have time. So my first question is, how do you see broadband evolving? And we'll start with you, Bora, if you have any insight.
Yeah, and thank you very much for the opportunity to share our perspectives. Actually, we see the broadband as a vital demand from the end users, and there are certainly many different technologies that might really, address connecting people with a broadband activity. But when we look into the details, we see that fiber is the only answer, no matter what the other technologies are. For instance, as Arpit put it very, well, even mobile side, mobile broadband, like 5G, 6G, will need fiber to carry on the data once it's reached the base stations. So I guess we're going to lay down fiber, whether at the access layer or the backhaul, midhaul, or front haul layers. It's just going to be all about fiber, and it will bring in efficiency and speed to address the ever-growing broadband demand from the end users. And disaggregation will help this even further by bringing competition and automation.
Great, thank you. Mitya, same question?
Yeah, so I will address a little some other views. So we are now, let's say, in the period of transition. So from technology from GPON, XGS-PON is now being widely deployed. And we see quite interesting situation on the market. So there are some effects of this global political situation, this vendor locking, and operators are really looking to have a solution that will be more future-proof without this vendor locking, easy to integrate another vendor, different hardware. So this is becoming very important. Operators wants to have a choice of selecting and not struggling with difficult integration and interoperability. Then it depends also this evolution from market to market situation. So I will give an example, the UK market. They invested quite a lot. So a lot of new operators was established on the market. They constructed a lot of the network. However, their take-up ratio is relatively low. So they build the network, home passed is okay, but homes connected is still, they're still struggling with this. And on the other hand, the investors are pushing the operators to open their networks, to make them available as a wholesale to the other ISPs, or already consolidation is starting to happen. So operators are merging or being acquired by others. And then again, you need to integrate various network equipment into the same ecosystem. And that brings up again how important it is to have a standardized solution, to have an open solution where you can offer the services to different ISPs and easy integrate equipment from other vendors. So this, I think, it's very important. And yeah, we see the evolution. So luckily, the Linux Foundation, the Broadband Forum are providing next versions of the solution, how to cover also these segments. So segments of wholesale offering, integrating equipment, offering additional services and functionalities.
Great, thank you. Carla, same question to you. How do you see broadband evolving?
Yeah. From our point of view, network disaggregation is a process that happens through vendors and operators and shared experimentation between vendors and operators. This process is not standard, is not one size fits all, but is flexible, customizable, and adapt to the specific need of each country. Our recent experience showed that full compliance with the BBF standard, especially NetConf is essential to promote further interoperability between management platforms and value vendors for both white box OLTs and traditional OLTs. Achieving this goal is a key focus of our effort.
Great, thank you. And some of you have already touched on this, but what do you think, or how has open source software helped to disaggregate the broadband ecosystem? Bora, you want to start with that?
Yes. I mean, looking back our journey that we've been through in ONF and the Linux Foundation, open source is all about collaboration. And collaboration means multiple parties to work together to achieve, you know, a pre-integrated end system, end goal. So open source is really helping making it much easy to actually align multiple parties' efforts. It helps actually align the requirement part as we were working with service providers. We've been hearing from them what they are actually trying to achieve. And we've worked with other supply chain partners to build that software together. And this really actually makes it possible and much easier to come up with a disaggregated solution. So open source, I guess, is key to actually to present a foundation for a disaggregated world. And also, in general terms, open source is always a mechanism to actually fill in the gaps where standards does not exist. And it also speeds up the whole cycle from idea to implementation, and really eliminates misinterpretation of, you know, standard definitions and things like that. So to wrap up, I can say that open source is kind of really a very helpful mechanism to build software that ensures everybody's perspectives into one place, and also that speeds up the whole process from idea to implementation.
Great, thank you. Mitja, would you like to add to that?
Yeah, I agree. So Kontron, as a challenger in the broadband area, you know, we have to be more open, more flexible, more innovative than the biggest vendors on the market. So standards, open source initiatives are contributing that we can have a better solution, that we can do more interoperable solution, that there is no locking, that it's better security, more transparent, and so on. So it really helps us to develop better products, and it also connects us with various partners, players in the industry to make a stronger collaboration. So yeah, I think it's a good thing to have open source.
Okay. And Carla, over to you.
Yes. A fully open collaboration between suppliers is necessary because help to prevent potential compatibility issues in the best possible way, allowing us to anticipate complex deployment scenarios that often arise from past technological choices. The integration of configuration systems and alarm data connection can be defined a central objective. These should be common goals for all suppliers, facilitating smoother operational activities and improving the management of field devices.
Great, thank you. So I have one last question we should have time for. What do you think is one challenge that we need to overcome as a community in 2025? I know, Bora, you had mentioned a few in your introduction, but can you think of a specific one for this community to focus on in the new year?
Yeah. I mean, thank you again. I think I just want to remind everyone's how Mehmet concluded his presentation. He said ecosystem is the key. I think as a community for next year, we should all focus to achieve an even broader ecosystem, an ecosystem of service providers, equipment vendors, and software providers. We already have a very vibrant ecosystem in place, but more members and more contributions are always better.
Great. Meetup, same question for you. How would you, or what challenge would you think this community should focus on overcoming?
So, okay, besides we will have some, I think, political challenges next year, so which will impact probably also our market. So, but I would add here that is important is the know-how, the intellectual property, and it will become even more important. So, of course, open source here helps a lot. But I have in mind not just the software part, but also have the abilities to produce the product locally, to integrate with DevOps, with local integration on the market, because the world is changing and this local component is becoming more and more important. And yeah, we will have to work more to establish more know-how, to educate more engineers in this area in order to use the solutions that are being provided by the community and integrate them locally to different operators, to different customers.
Okay, thank you. And Carla, same question to you. Any particular challenge for 2025?
In my opinion, it is to promote new experimentation. It includes new operators and vendors in the Linux Foundation access process, focusing particularly on hybrid scenarios with legacy technologies and new open and disaggregated technologies.
Great, thank you. Well, I'd like to thank all of our panelists for attending and joining us on this session today. With that, I'd like to introduce Mahir Gunyal, who's co-chair of the VOLTHA Technical Steering Team, and Özge Ayaz, a VOLTHA community member and contributor, who are going to be giving a project update on VOLTHA. So over to you, Mahir.
Thank you, Michelle. This is Mahir Gunyal, Senior Technology Architect in NetSia, and also I am TST co-chair of the VOLTHA SEBA project. So I'm going to give a presentation about SEBA and VOLTHA project, the status and the overall architecture. Before that, to understand the motivation behind the SEBA, let's take a step back and look at the challenges operators face today and the SEBA's offering to these challenges. As the networks grow more complex, operators are striving for greater efficiency in their data centers. But traditional solutions are often siloed, making it difficult to integrate new applications seamlessly. SEBA addresses this by enabling operators to run software efficiently within their existing data centers, alongside the other applications they have, like mobile network applications they have, or core network applications, access applications, etc. But efficiency alone is not enough. Operators need solutions that are open and adaptable to their unique requirements. SEBA embraces a community-driven and open source approach, ensuring continuous innovation that aligns with real-world needs and also basically the operator needs. Another key challenge is interoperability. Operators deal with a mix of OLTs and ONTs from different vendors, which can lead to compatibility issues. SEBA's design ensures different ONUs can connect to different OLTs, providing true plug-and-play flexibility. Finally, there is the issue of vendor locking. Operators want the freedom to choose their hardware. SEBA achieves this through disaggregation, separating the software from the hardware. It can run on a merchant silicon server or virtual machines, allowing operators to take full control of their infrastructure. Together, these principles, the data center efficiency with SDN and virtualization, the openness, interoperability, and disaggregation forms the foundation of SEBA, addressing the most pressing challenges operators face today. Next slide, please. Now let's explore the SEBA reference design in a very high level, and the part that VOLTHA community currently focus on. The SEBA architecture is built to integrate both legacy and modern network components. At the core, it's VOLTHA. It acts as the PON management layer, and it abstracts the complexity of the PON and making it easier to manage and scalable. Starting from the OLT layer, SEBA supports a wide variety of the hardware, including legacy OLTs, white-box OLTs, and native OLTs. SEBA enables disaggregation by separating the software and hardware components. The hardware is transformed into white-box OLT hardware, while the control and management software are redefined as modular software components. This disaggregation not only modernizes legacy system, but also aligns them with the SEBA architecture principles of openness and flexibility. Each OLT type you see underneath, they connect seamlessly to VOLTHA through specialized OLT adapters. These adapters translate open or vendor-specific protocols into the SEBA standardized interfaces. For white-box OLT, we have in VOLTHA an implementation of open OLT interface via gRPC. On the ONU side, VOLTHA accommodates ONUs from multiple vendors, ensuring interoperability across different device brands and models. This flexibility allows operators to mix and match hardware from different vendors. And this is achieved by Open ONU implementation, which is OpenOMC and G988 compatible. The control plane functions on the middle, the yellow part, they are also disaggregated from OLTs and run in the SDN controller layer. These applications include DHCP, multicast, LLDP, PPoE, etc. for access, and also BNG and Fabric functions for BNG and Fabric controller as well. The network edge mediator on the northbound serves as an edge orchestrator and also fulfills FCAPS needs in the edge, collects alarms, metrics, and open APIs to the northbound systems. Together, all these components create a modular, disaggregated system that is both powerful and adaptable. And the next, please. Yeah. VOLTHA is packed with features to meet diverse operator needs and requirements. It supports AAA services like high-speed internet, IPTV, and VoIP. Offers multiple service models and technologies from GPON to EPON. Has comprehensive and advanced PON management capabilities. Includes advanced traffic management capabilities, like traffic classification, shaping, policing. supports multi-vendor devices, allowing seamless integration, supports in-service software upgrades for data plan continuity, and provides comprehensive security, software upgrades, and detailed telemetry features. Some listed here and some are in our software. Next, please. And we're very proud of it that the SEBA VOLTHA project is very mature and in production, working in the fields in different operators. You already heard from Türk Telekom, and you heard in Manuel for DT. You heard from Kontron about the Germany deployment they have, and also it's in production in Jayo and Ositjayo. So there are also a lot of lab trials, demos, etc. around the world from various operators. The benefits from operators feedbacks are clear: reduced capex and opex, multi-vendor support for easier onboarding, and fewer operation errors. SEBA so truly delivers tangible value to operators currently. Next, please. And as SEBA evolves, is what we're doing and what's next for us. We are committed to maintaining a robust CI/CD system, ensuring daily integrations, testing, and verification. We're focused on improving scalability by introducing a new controller now instead of ONOS, and optimizing resource usage. Lastly, we're focusing on aligning with industry standards to enhance the value of our already impactful open source software. One key initiative is the collaboration between LF Broadband and BBF through a dedicated Tiger team. You will hear more about that. I think Serkan and Fran will go through it in one of the next sessions. So with these advancements, SEBA will continue to provide operators with cutting-edge solutions for their evolving needs. And saying that is all from me today. Thank you very much for listening. And handing back to you, Misha.
Yeah, this is my part. I think I can start. Michelle?
Yes, please do.
Yeah, hi everyone. I'm Özdem from Axon Networks. I am senior backend developer, and today I will talk about Linux Foundation VOLTHA Open ONU adapter, a key component in the open source VOLTHA ecosystem, which support broadband access network solutions. And also we will explore OMCI LibGo and Deutsche Telekom, AT&T, and Türk Telekom OMCI diagrams. The Open ONU adapter boosts several critical features like Mahir's told about. Actually, VOLTHA feature set and Open ONU adapter is supporting all of this feature like software upgrade, multi-UNI support, and support different UNI types. Next slide, please. Okay. The Open ONU adapter product provides extensive support for a diverse range of ONU vendors, including industry leader like Zyxel, Broadcom, Alpha, and Sercom. This level of interoperability ensures that service providers can deploy multi-vendor solutions, and these ONUs have been successfully integrated into workflows used by major telecom operators such as AT&T, Deutsche Telekom, and Türk Telekom. Next slide, please. I want to little talk about OMCI LibGo because OMCI LibGo is crucial component in the VOLTHA ecosystem. It is a Go-based implementation designed to encode and decode OMCI messages fully complete with ITU-G 988 standards. This ensures seamless communication and management of ONUs in GPON and XGS-PON networks. And one of the key highlights of this library is it is extensive support for over 80 managed entities as defined by ITU-G 988 specification. And this emanates from the backbone of the ONU management, covering various aspects like configuration, performance monitoring, and fault management. And also this table here provides a snapshot of the library's components, showcasing coverage percentages for different modules. For instance, layer Go and messages types Go have 100% coverage. The overall design ensures that the library is both comprehensive and efficient in handling complex ONU management workflows. And also we can say OMCI LibGo is supporting two different OMCI messages. One of them baseline OMCI messages. It is has 53 bytes size. They just have different size. Baseline has 53 bytes. Extended OMCI messages has 1493 bytes. Next slide, please. And now I put all telecom operators, I mean AT&T, Deutsche Telekom, and Türk Telekom OMCI diagram. I put all of these OMCI diagrams because I want to show you how many complex OMCI diagram support by Open ONU adapter at the same time. AT&T just have one service and they are using one TCON and 4GEM, and they are separating all service via priority. Priority. Next slide, please. And Deutsche Telekom also has one service, and they are using 8GEM port and one TCON, and this OMCI diagram like that. And next slide, please. And Türk Telekom, they have three services, and HSI, WIP, and multicast. They are using 3 TCON and 4 GEM port actually for the multicast. Actually, all of them for the Ethernet UNI, also Open ONU supporting WIP and POTS at the same time. Actually, that's all I have talk about Open ONU adapter. Thank you.
Great. Thank you so much, Özge and Mahir. That was a wonderful update. It's great to hear how things are going with VOLTHA. At this time, I'd like to introduce Francisco de Carvajal from Radisys and Serkant Erlideria from Netsia to give an update on the SEBA reference design 2.1 work.
Hello, everyone. Good day. It's gone dark since we started this. I hope you can see me okay. Francisco de Carvalho, I work for Radisys. I'll give a very short introduction of my company in a few minutes in words. I haven't got any slides, you'll be pleased to know. Fantastic lead up to this topic that Serkant and I will present and give you an update on the good work that we've been doing in collaboration with the Broadband Forum. Title-wise, I'm the Senior Director for Integrated Solutions in Radisys, and I also have the pleasure of sitting on the Board of Directors for the Broadband Forum and also on the board for LF Broadband. So it gives us that glue between the two bodies. So, Kant, would you introduce yourself, please?
Yes, very briefly, thank you. This is Serkan Tulderya. I work for Netsia as an engineering manager, and also I'm a member of Broadband LF VOLTHA TSD. And also I'm co-chairing the VBF LF Alignment Tiger team with Francisco. Thank you, Francisco.
Yeah, thank you, Serkan. And I'm very grateful for Serkan to be helping on that work. We need more people. So this is a call to arms as well. If that area of work is something that you can help with, please talk to one of us and we'll take that forward. Very briefly, Radisys is primarily a software company. In the fixed space, we have ONTs, OLTs, we have the SDN solution. We have two variants of SEBA-based platforms, end-to-end. One is the distributed version, which has functionality primarily in the OLT, so very thin layer. And we also have a traditional centralized deployment, which is your classic pod for SEBA. That's enough for the sales pitch. We do have live deployments. Our largest deployment runs something like 200 OLTs a month in one tier one provider in Asia, right down to proof of concepts and everything else. And we're very active in the broadband forum, which is what I want to talk to you about now. Please, next slide. Okay, so this concept of a tiger team, and a tiger team is basically just a community of people that we have common interests. It's the broadband forum in particular has a mainstream work item where you put contributions, they're peer reviewed, and then they get put into technical reports or standard specifications. The tiger team kind of pre-leads that. So we've been working with the wider team in LFBB, Netsia, ourselves, Adtran, the service providers, Deutsche Telekom. We'd love to have Türk Telekom on board on the broadband forum and anyone else. So this isn't a single call to arms for anyone, but it's a growing community. And the Tiger team then delivers the analysis, the gaps, the requirements that would then go into the normative work, which is the second part, which is the analysis that we've done, and then the contributions that eventually make into technical reports. So today, we're going to talk to you about the overview. So what are the things that we've been working on? So OMCI, young model alignment, northbound interface analysis, and also the SEBA reference design. And then I'm also going to say a few words about what comes up next. Next slide, please. There is a background section. I think I've taken that away from the overall slide. If you could just go back one, please, Michelle, just very briefly, just to make that point. So there is a background section, and whilst I've taken it out of this deck so it doesn't get in the way, I'll put it back in. And when we share the slides, you'll be able to see why we're doing this, what the drivers were, and everything else. Thank you. Next slide. All right. So in a nutshell, there's a wiki page in the broadband forum where we manage the work. And there's a couple of recent contributions that Serkan and I have prepared, which just gives a general update. It's primarily what this slide is. This is a condensed version, so there's more. And then we've got the individual contributions. So we've now moved from why are we doing this? What are the drivers? What are the areas of alignment? What are the areas of collaboration? Through to actually, we've now done the analysis, and here are the contributions. This is our findings. We're getting to the stage where we can now create contributions that are peer-reviewed, that will end up in these technical reports. The main areas that we identified, this isn't an exclusive list. There are other areas that we'll eventually get to, but from a priority point of view, OMCI is critical to interoperability. I think Netsia mentioned a number of OLTs that they support, a number of ONTs that they support. In Radisys, we support over 52 ONTs in interoperability. It's a critical part of the SEBA solution. And so making sure that what we have in Open OMCI and the implementation of the SEBA and VOLTHA and what the Broadband Forum has in virtual OMCI and the technical requirements in TR 451 are completely aligned is key. And I think the good news is that it's pretty much there, right? There's nothing massively different between the two worlds that need addressing. However, that contribution to 4386 goes into more details. Device adaptation, if what makes you tick is device management, is controlling different types of devices, where southbound interfaces and how we migrate the VOLTHA API into the disaggregated access node technical report. We need more help. Serkan and I are working on that, but at a slow pace, right? There's a number of things that need to be done. So if that's your area, please get in touch, and we'd love to welcome you on board to help us with that. The solution doesn't work unless you integrate it northbound with OSS systems, with BSS systems. There's a number of work ongoing in the broadband forum for the northbound interface. SEBA has in their reference design a placeholder and a reference point and some good expertise in that area. Telecom Management Forum is another body. So there's kind of a three-way body of people working together to review the specs that exist, to build upon best practice from open source, and a release too, if you like, of broadband forum technical reports will come out, hopefully aligned with what SEBA already does. Another critical part is the Yang alignment. I think I would say I'm glad to say that when SEBA and VOLTHA first started, the first thing that they did is, right, who has defined the network models, the Yang models that would allow devices to be managed and controlled? And so TRs 383 and 385 were used from the beginning. However, there were changes. You know, the concept technology profiles is critical to our solution. It allows technology independence. It allows the interoperability that all my colleagues have been talking about. And so making sure that the technical reports and the Yang models in the broadband forum have inbuilt technology profiles, that any parameters that we've identified are needed are fed back, and anything new that the IETF, that the broadband forum has decided is also needed for evolution of Yang models, are baked back into the VOLTHA ecosystem. So that's what that work is about. And then lastly, but not least, so I've talked a lot about the broadband forum. What about the other side? Well, actually, the world of SEBA VOLTHA is a lot simpler. There's two things. There's the reference design, which is kind of the glue and the architecture and the reasons and the whys. And there's VOLTHA and the software themselves. It really is that simple. So I view that the SEBA reference design is the placeholder, the gospel, if you like, the Bible for all solutions. And so there are some things that we've identified in doing this gap analysis, specifically the SPI, the NetConf Yang, that we're looking at doing an uplift, if you like, to the SEBA reference design. As we do that, hopefully, if there's any inconsistencies, the world has moved on, anything else that the reference design needs updating with, we will try and do that. It's not the primary focus, but we will try and bring that document as up to date as we can. And of course, it will go for review with the TST and the community. And again, there is space for contributors in that scenario. If there's a particular topic that the SEBA reference design 2.0 has moved on and that we ought to refine, again, please get in touch with Michelle, with Serkan Tarai. And I think that's enough for me. Let me just pause a couple of minutes in there. Are there any questions on these couple of slides before we move on? All right, I think Serkan, you're on next, right? Next slide, please. Okay, so Serkan is going to cover some of the work that we've presented recently at the plenary for the Broadband Forum. Serkan, please.
Thank you, Francisco. Next slides, please. Before I delve into the specifics of our collaboration with the Broadband Forum, I want to quickly refresh our understanding of our SEBA's integration points with the broader BBF cloud central office architecture. Primarily, SEBA aligns with the BBF class C architecture at two primary points. At the northbound, SEBA's northbound interface will align with BBF TR411, which enables seamless integration with higher level network functions and the orchestrators. At the southbound, the interface between SEBA and access devices like OLTs will align with BBF standards like TR413, TR451, and TR477. That also ensures the interoperability with various access technologies. So these alignments are part of our ongoing collaboration, as Francisco mentioned, and this interoperability and with broader industry standards, we are continuing to collaborate with BBF. So to enhance the alignment, we created 3 different contributions until now in the BBF. Next slide, please. The first one is the BBF LF collaboration northbound interface analysis, which we are identifying necessary changes in SEBA's northbound interface to ensure the compatibility and with the BBF standards. It is important to note that SEBA NBI is designed for broadband access solutions, which prioritizes the simplicity and ease of integration, whereas BBF standards utilizes Young models for complex data modeling and are mostly suitable for structured and extensible broadband management. So the BBF LF Tiger team will continue to follow the activities in the BBF in different areas, since some of the work is still ongoing in the BBF side. For example, intent-based APIs is planned to be finalized at the end of the next year. TR411 issue 2 is about to be finalized, but it is mostly focusing on the inventory and topology side topics. And also the topics related with the FCAPs are still ongoing in the BBF side. So our plan, the first initial plan, is to update the SEBA reference design first, and reviewing it as a whole. We want to ensure it includes up-to-date information, also deprecating out of the date items. We expect very few changes in the SEBA reference design document to align with the BBF standards. Next slide, please. The next contribution we have done is the virtual OMCI analysis with comparing the BBF TR451 specification. By the comparison, we identified the SEBA's OMC implementation, which areas to be for improvement, open for the improvement. One key area is the MV-OLT-MF and virtual OMCI interface, where we will need to adopt PAM Young models to ensure the alignment. The other interface we are focusing on is the virtual OMCI OLT interface, which is the interface between the OLT device and the virtual OMCI function. And we don't foresee many changes to this interface, as they are quite similar. And we are planning to, as a next step, we are planning to prepare proposals to present to the LF Broadband TST, and we need to allocate some resources for the actual implementation. Next slide, please. Another contribution is the BBF Young to LF Broadband VOLTHA mapping and gap analysis to further enhance the alignment. We are mapping the available BBF Young models to LF Broadband VOLTHA. We have found that LF VOLTHA service models can be directly mapped to BBF Young models with minimal effort. We are also collaborating with different teams in BBF to examine the models, assumptions, and refine the mapping process. That is all contributions we have made so far, and that is all I will tell about these contributions. If you have access to BBF Jira tools, you can examine each contributions, and also you can welcome to make comments. Francisco, back to you.
Thank you, Sir Kant. Next slide, please, Michelle. All right, so what next? Yeah, next slide, I think. Is there something on that? All right, so as Sir Kant mentioned, we dug out, we dusted it, We got it up for sharing, and I've personally made some changes to the SEBA reference design 2.0. Right now, it's internal between a few of us to look at consistency and do some updates, but that will come out. The updated SEBA RD will come out, and I'm sure there's other things that we can tidy up as it kind of goes along, really. So as I said, there's a number of things that we can choose or not choose to do in terms of a roadmap. I have some good ideas. Interoperability is key. VOLTHA has proved that. However, and there's a bit of a however there. I think most of my colleagues, if not all of you, have mentioned TR413 and NetConf-YANG. That's the reality of brownfield deployments. And if we want to grow our market, if we want to get adoption of SEBA-based solutions out there, at some point, there has to be some support of NetConf-YANG. Oh, but it's not as interoperable. No, it isn't. And actually, that's a brilliant opportunity for us to showcase how interoperable the solution within SEBA reference design and VOLTHA is. So there's a little bit of work, as well as the SEBA reference design. As we move forward, then actually it makes sense. We don't want to reinvent the wheel. So if we're going to have things such as NetConf-YANG support, well, actually, let's just make it aligned with whatever Broadband Forum has already done. It will go to the TST. It will need review, and then we move on from that. We currently have a baseline Word document that's open for edits. Bracket looks the wrong way, but it doesn't matter. I think you get the message. I had to take that offline to do that first draft, but I've shared that with the team, and we'll make it available in due course. Now, I think there's one more slide, if I'm not mistaken. Just giving you information. So next slide, please. Okay, so join us. We have a mailing list. There are different levels of membership in the Broadband Forum where you can watch. You know, if you want to be a proper member and contribute, then that's a different membership. But there are cases where you can get access, certainly to all the technical reports that are public. Everything that is published from the Broadband Forum is open. So you can look at that and you can observe the work. If you want to contribute, then talk to us about how to do that. There's a lot of information already captured in this subject, and we have weekly calls. On Thursdays, you can see that the time zone tries to adapt and cover the world, but it doesn't always work, right? West Coast starts early, India kind of ends late. We're in the middle, we're okay. You know, pretty much that is the end of our presentation. I hope that you've found it interesting, and I look forward to getting questions, comments, and of course support. So do reach out, and we'll have a conversation. Thank you.
Great. Thank you both for the update on the reference design work. At this point, I'd like to bring back Arpit for some closing remarks.
Okay, thank you. And let's go to the next slide. I think it's just one slide. But if you need to contribute, but more importantly, learn, it's very simple 3 steps. Get a Linux Foundation ID, go to the wiki, and then just join. And you don't have to just be coding. You could do pull requests, you could provide feedback, you could answer questions, you could do a whole bunch of things, including documentation. So we're looking forward to everyone participating. This is a global initiative. As you saw from our excellent speakers and deep technical folks, this is the way to kind of build a global community of open source ecosystem. And we have done it across multiple areas of technology. So we're looking forward to all of you all participating. Thank you all for joining, and again, really appreciate everyone on the panel and speakers to be giving insights about all of these things. I think we've answered all the questions on the panel as well. Yes, we have. There are no more open questions. So thanks a lot. And with this, we will end this webinar.